All right, this is the third example of graphing a rational function. This time I've picked this example for two reasons. The first of which is we're going to have two vertical asymptotes. So, and a lot of the problems in the book are going to work like this. Your process is exactly the same. So here goes. The vertical asymptotes. In fact, we did this problem for vertical asymptotes in the previous video. What you do, you take your denominator equal to 0. I'm going to factor that. So the two factors of -6 that add up to -1 or -3 and +2. And what that gives us is two vertical asymptotes. One is at x equal to -2, and the other is at x equal to 3. If I did that too quick for you, go back to the vertical asymptotes video. We do that with a little more detail. The horizontal asymptote. This is the situation where the degree of the denominator is bigger than the numerator. So that means the horizontal asymptote is automatically y equals 0. The y-intercept happens when I plug in 0 for x. So in the top, I have 0 plus 1. In the bottom, I have 0 minus 0 minus 6. So -1/6, so just a little bitty bit below the origin. The x-intercept happens when x plus 1 over x squared minus x minus 6 equals 0. Well, again, a fraction can only be 0 when the numerator is 0, so x plus 1 equals 0, so that happens at x is -1. Does the graph cross the horizontal asymptote? This is another reason I picked this problem, because for the first time we're going to see that the answer is yes. So here goes. I take my graph, my function, and I set it equal to the value of the horizontal asymptote, which is 0. When I multiply both sides by the common denominator, x squared minus x minus 6, notice what happens. I end up with the same equation we just solved a moment ago. 0 times anything is 0. And indeed, this does cross the horizontal asymptote at the value -1. But notice this. It doesn't cross it anywhere else. After that one time at x equal to -1, it will never cross the horizontal asymptote again. So we can now rest assured that the horizontal and vertical asymptotes are going to be firm, except for the horizontal asymptote at this point right here. So now I come over to my graph, and so my vertical asymptotes happen at -2. So dot right here at -2. The next one happens at +3. So dot right here at +3. My horizontal asymptote is y equals 0, which is just the x-axis. So I know that you probably can't see it real great, but I am making a dotted line right on the x-axis. My y-intercept is at -1/6, so just a little bitty bit right here. The x-intercept is at -1, so right here. And now I just need to get some information. So what I'm recommending you do is this. First, for on the outsides, we know the graph is not going to go through the vertical or the horizontal asymptote. So just get 1 point in each of these areas to figure out where the graph's going to be. Here, we could actually complete this. The graph goes through the horizontal asymptote, and then we know that it's going to just continue up, up, up like this. It's never going to go through. But I just want to give you a little bit clearer picture of what's going to happen. We know the graph's never going to circle around and come up through the horizontal asymptote again. It only goes through that horizontal asymptote in this one place. So I'm going to get a point over here, a point here, and a point here. So I'm going to plug in -4, I'm going to plug in 2, and I'm going to plug in 5. Okay, so I'm going to come back over to this other board. We're going to do a little arithmetic, and then we will all be through with this problem. So I'm going to first plug in -4. So in the top, that's -4 plus 1. In the bottom, -4 squared is 16, minus a -4, so that's +4. So -3 over 14, so just a little bitty bit. I said I was going to plug in the value 2. So in the top, 2 plus 1, and then 2 squared is 4, minus 2, minus 6. 4 minus 2 is 2, minus 6 is -4. And then the last one, I believe I said 5. It really doesn't matter. You can pick any values you want. And then in the top, I have 5 plus 1. In the bottom, 5 squared is 25, minus 5, minus 6. So I have 6 in the top. 25 minus 5 is 20. Minus 6 is 14. So here we go, finishing up this problem. We're almost done. Over here, when I put in negative 4, so 1, 2, 3, 4, I got negative 3 over 14, so just a little bit below. Well, again, my asymptotes define the behavior of the graph, so my graph is going to look like this. If you would be more comfortable plugging in a few other points, then go for it. When I plugged in 2, 1, 2, I got the value negative 3/4. So we can see there is a very slight decreasing right here. So I'm going to finish the graph just like this. It's going to look something like that. And then when I plugged in 5, so 4, 5, I got 6 over 14, which is just right around a half. So once again, the asymptotes define the behavior of the graph. Don't go through those asymptotes. And there is my graph. Lots of detail. It's just a sketch. And get as many extra points as you need.